Very good afternoon. Very good afternoon. I am audible. Am I audible to everyone? If I am audible, please reply. Okay. I think many students are about to join. Okay. So I'm just repeating this concept. Yesterday we have discussed related to the SHM in the uniform electric field. That was our concern in the last class. So we have seen one thing. Very basic thing. When the one pendulum is there, when simple pendulum I am putting here. Chandana Shri, very good evening, beta. Swati, good evening. Okay, I am audible to everyone. Please reply. Very, very good evening, all of you. I am audible, beta. Please reply. Very good, beta. Swati. Other person also please reply. If I am audible to everyone. Mandeep, very good evening, beta. Okay. So now I am going to start the things in the last class we have discussed this question. Okay, if the simple pendulum is there, length L of string length is L. Okay, string length is L, and there is one bob of mass M and charge is Q. If you are putting it, and there is one electric field is acting vertically downward direction, then we have to calculate what is the time period. So time period we have seen we have to calculate the net downward force, vertically downward force. So we have seen the net force is mg plus qe, that is equal to mg effective, and g effective is equal to g plus qe by m. Okay, we have got this answer. Okay, beta, say good evening, beta. Now from that we can write the g effective. Earlier time period was t equal to 2 pi under root L by g. Okay, and t prime is equal to 2 pi under root L by g effective, we can put it. Understanding? So using this g effective term, t prime is equal to, we have calculated 2 pi under root L by g plus qe by m. This was the time period that we have discussed last class. This is the one shortcut way to get the answer, because I have not discussed how to get this answer, but directly I calculated the g effective and we put the value and we get the answer. That is the one way. That is the one way to get the answer. But don't worry. I will explain in detail also this question again today. Okay. Second question, I am just reverse this electric field direction. Now it become vertically upward, not vertically downward. Then also you can write the g effective, because the net effective force downward is mg minus qe. That is equal to mg effective. That means g effective is equal to g minus qe by m. And we get the answer, that is t is equal to 2 pi under root L by g minus qe by m. This was the question. We have got the answer. Okay, this is a very basic question, very basic question, beta. So we got this answer by using this shortcut method, but we will explain today in detail also. Okay, one more example I have given in the last class. That was the one pendulum is there and you are putting horizontal electric field. That value is E. That value we are putting E. Using this E, there would be one horizontal force that is equal to QE, and downward force is mg. Using this vector calculation, we can get the F net. What we can get? F net, and F net is equal to QE whole square plus mg whole square is equal to mg effective, and g effective value is equal to under root of g square plus QE by m whole square, and from that we get the time period. This all calculation we have done in the last class. It is clear to everyone. I am just repeating this part so that everyone would be clear about these two questions. Everyone is clear? Clear idea, beta? Chandana, Swati, Mandeep, Sheikh. This question is clear to everyone, beta? Please reply. Clear or not clear? Chandana, Swati, Mandeep, Sheikh. Okay, beta. Mandeep, very good, beta. It is clear to you. Other person also reply. Reply. If you are replying fast, that is a good. Okay. Now, using the actual concept behind it, how to calculate this SHM, I am just explaining the few things that you have to understand. So I am putting here the SHM concept. Please understand first. Suppose there is one simple pendulum. I am taking to the next slide. That would be better. This is a simple pendulum case. I am putting it. This is simple pendulum. This mass is m. Now I am not putting any charge here. I am just putting mass m and length is L. So how to calculate the time period? We have to understand it. So we can put it. So Dakar, very good evening, beta. We are putting it. Okay. So we are putting this angle is suppose theta. This angle is very small. This theta is very small. Very small. Try to understand. It's a very small theta. So using this theta, we are putting this how much the time period, how to calculate the time period, that is our concern. So how we calculate, understand clearly. So we put the forces here. What are the forces? One force is mg, another force is tension. Using these two forces we get the calculations. Now try to understand. This is the mg is there. This length is L. This is a tension. Tension is acting along this string. Tension is acting along this string. This point is O, beta. This point is O. This length is L. This length is L. This string length is L. And this point of hanging is O. And this mass we are saying that is equal to m. So the mg is having mg. This is the mg. Now mg is having two components. Mg is having two components. This angle is theta with the vertical. That means this angle is also theta with the vertical. Now what you can say, this is mg cos theta. This is mg sin theta. This is mg cos theta. This is mg sin theta. So for any point I am writing this tension and mg cos theta. These two forces, tension and mg cos theta, passing through this center. Passing through this center. Center means this point of hanging, point O. This passing from point O. That means their tension, their torque about O would be 0. So torque due to tension is equal to 0. Torque due to mg cos theta is equal to 0. So torque is only supplied by the mg sin theta. Torque is only supplied by the mg sin theta. So you can say torque is equal to mg sin theta, beta. And what is the length here to here? That length is L. This is the torque. And definitely it is a restoring torque. We can write it. That is a restoring torque. We can say that is equal to I into alpha. I is the moment of inertia. Alpha is the angular acceleration. I is the moment of inertia. Alpha is the angular acceleration. And we know the theta is very small. So for a very small theta, we already know sin theta is approximately equal to theta. So you can say mg into L into theta is equal to I alpha. And from here you can say, sir, alpha is equal to mgl divided by I into theta. This equation we can write it, and this same equation we can say, because this is the restoring torque, so we can put it minus sign here, and that is equal to minus omega square theta. It is SHM equation. It is angular SHM equation, beta. Angular SHM. It is angular SHM equation. This is equation 1. This is equation 2. Both equations we are seeing. This is from SHM. And this equation we are writing from here. So we are getting answer. So what is the omega? Omega is equal to under root of mgl I value. What is the moment of inertia about this? Because this mass is m and length is l. So mr square, or you can say ml square. So m is cancelled, one l is cancelled. Omega become under root of g by l, and you are getting this time period that is equal to 2 pi by omega. That means 2 pi under root of L by G. Everyone remember. Now the many student will say, sir, you are wasting our time. This already we have studied in the 11th class. In the 11th class we have studied. Nothing is difficult in this part. Sir, we already know what is time period. Why are you driving it? Why are you wasting our time? But my concern is there. If you are not understanding this, the next question you cannot solve. So I'm asking again, this concept is clear, this derivation is clear to you or not, beta? Please reply. Sudhakar, Chandra, it is clear? Mandeep, Swati, Jason, it is clear to everyone? It is clear, beta? Sudhakar, very good, beta. Very good, very good. Please. Mandeep, very good, beta. Other person also put. Clear? It is clear or not clear, beta? Very good. Now it is clear to you. Now this concept you understand it, then you can solve the next question that you have to understand it. That is a very important question now. Please focus. I am taking to you the next problem. What is next problem? You will say, sir, this is the one charge particle. This charge is suppose Q1. This charge is suppose Q2. This mass is M. This charge is Q1. This charge is Q2. This mass is M, and this length is L. And this is hanging about this point. And it is oscillating. This pendulum is oscillating in this part. Like this. It is oscillating. This charge is Q1. This is Q2. This mass is M. Both are positive or both are negative. I am putting it. Then they are repelling each other. Now question is that what is the time period of this system? What is the time period of this system? What is the time period of this system? Okay, that we want to solve. That we want to solve. So how to solve this question? How to solve this question? That is our concern. If you understand this concept, you can solve it. How to solve? Focus. I am putting it. After some time you will say you are taking in a rightward direction by some angle theta, and again the theta would be very small. Theta would be very small. This theta value is very small. We have to put it. Now if you putting it, what are the forces acting here? You have to see. What are the forces, beta? This one force is directly vertically downward, mg. One force would be tension. One more force is acting. Can you tell me what is one more force? What is the third force is here? Tell me what is the third force acting here? One is mg, one is tension. What is the third force? Tell me the value, beta. What is the third force acting on this charged particle? Q2. What is force? Electrostatic. Very good. Other person, please reply. What is the force? What is the force, beta? Chandana, Sudhakar. Centripetal force. Very good. Swati, Sheikh, Jashin Bhai. What is that force? Force of attraction between the force of attraction or force of repulsion? Sudhakar beta, force of attraction or force of repulsion? Very good. This is the force of repulsion is there. Force of repulsion is there. That you have to apply. If you are applying it, that the outward like this. This is the force of repulsion beta. Electrostatic force. Now think carefully. Again you have to take the components. Again you have to take the component. What are the component here beta? Check it. The components are very simple. You can put it. That one component of mg is this direction. One component of mg is this direction. That component is again this angle is theta. You will say mg cos theta. This is also mg sin theta. It is mg sin theta. So what is giving you torque? What is giving you torque beta? Torque is given by only mg sin theta. Tension is not giving torque. Why not giving? Because tension is passing through this point of hanging O. This tension is passing through point of hanging O. What is the Fe? Fe is also passing through point of hanging. That means tension and Fe is not giving you any torque. Any torque. Neither mg cos theta is giving you any torque. Who is giving the torque here? Mg sin theta. Who is giving torque beta? Mg sin theta. Again you will say mg sin theta into L is equal to I alpha. This is same force we are writing it. Same torque we are writing. Now check in the left hand side. We are writing the same torque here also. Same or different? Same or different? Reply beta. Same or different? Left hand side, this side, or this side, right hand side. Both torque same, different? Reply beta. Same or different? This force is a understanding. Sudhakar, very good beta. Chandana, Mandeep, Swati, reply beta. Same or different? Jason bhai. Reply beta, reply. Very good. This is same. If same, that means here also time period would be same. Time period would be same. Time period is equal to 2 pi under root of L by G. Now there should be no confusion कि sir why electrostatic force or G effective concept is not coming here. That's why I explained in the left hand side what is the meaning, how to calculate the time period. How to calculate the time period I explained you first. That's why I am writing here time period would be 2 pi under root L by G. It does not depend Q1 and Q2. It does not depend on Q1 and Q2. That means here no need to write G effective term. Clear beta? Chandana, Sudhakar, Mandeep, clear this thing कि time period would be 2 pi under root L by G. Clear or not clear beta? Please reply. This concept is clear. This question is clear to everyone. Reply it, beta. I will take to you the next problem. The next problem is there, beta. Please focus. I am putting here. There the one spring is there, beta. It's a spring. And on this spring, this mass is m. Charge is q. This mass is m. Charge is q. And it is placed. And now the field you are putting it, electric field. Now question is that what is the new time period? What is the new time period? That is the question. How to solve it? This question we want to solve. What is the time period? I am giving you this time, how to calculate this time period. Again, first you have to understand this question. Question is this: calculate the time period. Calculate the time period of block of mass m. This is the question. This question we want to solve. But before solving this question, we have to understand. What we have to understand, beta? Very basic thing is there. It is given to you. What is given? Here, just check. Suppose there is no mass, there is no charge is there. There is no charge. Only this mass is m. This mass is m. Initially at equilibrium position or natural length. It is your natural length. It is your natural length. And using this natural length, I want to extend this block from its natural length. I want to extend this spring up to certain length. This is the extension is suppose x. I am not taking any charge. I am solving first basic how to calculate this part. So this is the extension is x. This extension is x. So there would be one force on the block. What is the force acting in the leftward direction? Spring force. And that spring force is equal to how much? Kx. And definitely it is a restoring force. So you can put minus kx. This spring force is equal to minus kx. Because extension is rightward direction. Then force would be leftward direction. If you take this block in leftward direction, then force would be rightward direction. Means opposite to this x. It would be the force. It would be force. It is the restoring force. And that force is equal to ma. This force is equal to ma. Using this ma, we can calculate acceleration. What is acceleration? Minus k by m into x. This is the equation. And this same equation we can relate with the equation of SHM. A equal to minus omega square x. This is the equation of linear SHM. It is the linear SHM. This is the equation of linear SHM. We have to compare. We have to compare both equation 1 and equation 2. What we will get, beta, from equation 1 and 2? From equation 1 and 2. What we will get? We will get omega is equal to root over k by m. That means time period is equal to 2 pi under root m by k. 2 pi under root m by k. Now every student can say that this also we know already from 11th class. This time period we already know from 11th class. Again you wasted our time. But first tell me this concept, this derivation is clear to you? The derivation is clear to you? Clear or not clear, beta? Please reply. Sudhakar, Mandeep, Chandana. Please reply, beta. Swati. Reply it, beta. Clear or not clear? Very good. Other person also please reply. It is clear or not clear? This concept is clear, beta. to everyone? Very good, beta. Other persons reply. Reply fast. Now, using this concept, we want to solve this above problem. Using this concept, we want to solve this above problem. How to solve? Please focus on the board. If you say, sir, this is the spring mass system. Suppose this was the initially spring mass, and this is the natural length. It is your natural length. It is the natural length. And you are extending from here. You are extending from here some length. Now, try to understand natural length, or better term is to use it one more word, that I am extending. Why it is extended? There is one more thing is there. Try to focus here. This mass is m. This is not oscillating right now. It is not oscillating. Now you will say, why will not oscillate? You extend it. I am not extending, beta. There is one electric field is existing, and there is electric field is existing. Now try to understand. Try to understand the concept. What is the concept? This is Q. This is E. So due to Q and E, there would be electrostatic force. There would be electrostatic force. So this direction, right hand direction, there would be electrostatic force, that is equal to Q into E. And this extension I am saying, suppose X naught. This extension I am saying X naught. In leftward direction, there would be one spring force. There would be some spring force. So this you will say, sir, spring force is equal to Q into E. What is the spring force? You will say, sir, K X naught is equal to QE. So this X naught is equal to QE by K. You can write either this way or you can write this way. This is nothing else equilibrium position. This is we call equilibrium position. Now there are two things is there. Now there are two questions comes to you. Very first question. Natural length is always equilibrium condition. Natural length is always equilibrium condition or equilibrium position. First option. Statement 2. Natural length can be or may be a equilibrium position or may not be an equilibrium position. Statement 2. Statement 1. I am repeating again. Natural length of a spring is always a equilibrium position. Statement 2. Natural length of a spring may or may not be an equilibrium position. Which statement is correct? 1 or 2? Which statement is correct? 1 or 2? Chandana, Mandeep, Sudhakar, Swati. Please reply, beta. Which statement is correct? So what we are seeing in here, it is not natural length. It is not natural length, but equilibrium position is somewhere else, not at natural length, because here the forces are balancing each other. Here the forces are balancing each other. That means this is the equilibrium position. It is the equilibrium position. So at this equilibrium position, you can see that it is not natural length. Now take this part further. You are extending now from this equilibrium position to further. Now you are extending further from this equilibrium position like this. You are extending further. So this was the position from here. This was the natural position here. This distance already X naught is there. This further you extend X. You further extend X, beta. This mass is M. This charge is Q. And you are applying a force, electric field E. You are applying a electric field E, and this is the K, spring constant K. Can you see this diagram? If this diagram is clear to you, because this X naught is the equilibrium position. From this equilibrium position, I am extending it further X. Further X. Now we have to see what are the forces acting on it. There is no space. Definitely I am taking to you the next slide. You will understand. So what you will see, there's the one block. This was the block. On this block, right hand side, this force is QE. Right hand side, this force is QE. Left hand side is the spring force. This is the spring force. Definitely it is different from previous part. Praveen, very good, beta. This is the spring force. So what you will say, the net force is equal to spring force minus QE. Spring force minus QE. What is the spring force? K. X naught plus X. Because total extension is now X naught plus X. Total extension is how much? X naught plus X. Okay, minus QE. Minus QE. This is your net force. And definitely it is a what? This is force, is total force. This total force is again restoring force. Again this restoring force, I am putting a minus sign here. So you can put it. The minus, this is K. Okay, you can say X naught plus Kx minus QE. I can write like this. This is net force. Clear? This line is clear, beta. Kx naught plus Kx minus QE. This line is clear, beta. If it is clear, that go to the back slide. You will see Kx naught plus is equal to Kx naught is equal to QE. Kx naught is equal to QE. Kx naught is equal to QE. If you see here, this is the Kx naught. This is QE. Both are equal. That means they are cancelling each other. Then what this become? The net force become again minus Kx. Oh, what is this? F net is equal to minus Kx. This is a very simple force. What we have seen in the previous slide also. Here that is equal to F net is equal to minus Kx. This was the net force. And if this is the force, net force is this. That means what is the time period? What is the time period? 2 pi under root m by k. We have already tried. 2 pi under root m by k. So 2 pi under root m by k, that means here also if you see the what is time period, directly you can write from this, the time period is equal to 2 pi under root m by k. This is the time period. This is the time period. This is the time period. What is the meaning? Here charge is present. Even charge is present. Charge is present, but still what is not changing? This time period is not going to change. So I have given you two examples. One is from simple pendulum where time period is not changed due to charge or electrostatic force. Here also the spring mass system. Here also it is not changing. Again the same question. I am giving you another question to you. What is the time period for this case? Please solve this question, beta. There the one spring is there. This mass is m. Spring constant is k. If it is oscillate here, I am giving you already. This time period is equal to 2 pi under root m by k. This time period is equal to 2 pi under root m by k. You can solve it by the same method what I applied. Okay, but I am asking, this is a one part, it is given to you. This 1A question I am asking. 1A question I am asking. Okay, suppose this is the spring mass system, but its mass is also having charge q, spring constant k. Now I am applying a uniform field E. It is a uniform field E. It is the uniform field E. Now question is that what is the new time period? What is the new time period? This is the question. So please tell me first, this line is clear or not clear? Please everyone reply. Vamshi, Sudhakar, Praveen, Chandana, Mandeep. Please reply. This is clear to you or not clear, beta? Clear or not clear? This previous question is clear to everyone. Sudhakar, Vamshi, Praveen, Chandana, Mandeep, Swati. Clear to everyone, beta? Swati, very good, beta. Vamsi. Very good, beta. Very good. Okay, you like the one is maybe some students are liking the video. They are again putting some hearts. They are pushing it in the. I think the in chat box some option is there. They are putting again and again heart. They are sending it. So sometimes I am a physics teacher. Very rarely physics teacher get this heart in the class. Okay, heart they are putting it. Okay, if you are liking it, I like that thing. If you are putting it, yes, that's the good. If you like the things, you can put the heart. That will look some good. Okay, very good, beta. Now this concept is clear to you. If it is clear, put this question. There are two. I have given you one example. Very good, beta. Now solve this question and tell me what will be the answer for 1A. Similar question I have given. It was horizontal, in vertical. I already told you this time period is this. No need to calculate. Now tell me what is the time period here. What is the time period here? Chandana. Very good, beta. Very good. There would be some fun in the physics class also, na? I like that thing. So you are putting it. That's a very interesting. Very good. Okay, solve this question. Tell me the answer. What is the time period? Here would be also time period. Same or different? 2 pi under root of m by k. 2 pi under root m by k. The same we have derived. Similarly we can derive it. It depends only on kx. The net force will come again. Time period would be how much? Again kx. This line is clear? Chandana, Mandeep, Vamsi, Swati, Praveen, Sudhakar, it is clear to everyone, beta? Please reply, beta. Chandana, Mandeep, Vamsi, Swati, Sudhakar, Praveen. Reply, beta. Very good, very good. It is clear to everyone. If it is clear, I am giving similar question. Now you will answer me. This is second question. If I say this is the beta 1 system, spring mass system, this mass is m. I am telling you again, time period is same. 2 pi under root of m by k. Don't worry about it. No tension. Directly I am telling you, you can derive. Okay. Now think carefully. 2A. Similar question I am giving you. Suppose here also you are putting it. This spring constant is k. Now this mass m having one charge q also, and you are putting external field, uniform field. That is a uniform. Again question. What will be the time period, beta? New time period. Tell me, beta. Similar question I have given to you. Everyone reply in the chat box. And if you are, please reply. What is the time period? Everyone reply. Similar question. Similar question. No doubt about it. Similar question, beta. What is the time period? Apply it. Swati, Vamsi, Mandeep, Sudhakar, Chandana. What will be the answer, beta? Please reply. Beta, in the physics class, don't sleep. Okay. I know this is time for your sleeping time. Is there? It is summer time, na? Having a AC or cooler or fan just on, we are sleeping. No doubt, nothing is problem. But no, this is a time to learn. If you learn it, you will achieve it. Okay, this is a time you have to perform. You have to fight. If you are fighting today in this age, then only you can achieve the big goals in the life. Okay, you have to fight for it. If you are fighting, then only you can get it. So in the class, when you are attending it, maybe it's an online class, very in a Monday onward, we are having offline classes also going to start. When you join it, you should be very focused from day one. You should be very focused. You should make proper notes, write it, remember them, revise it, solve the questions. If you are doing that much work, then only in the final paper you are going to perform. Okay, please, what I'm telling you, please understand those things. Very first thing, you should be very focused. You should write proper notes. Don't depend on any other person. Okay, my friend is writing or my classmate is writing, his handwriting is good or something is good, we can take the notes from someone else. No, definitely not like that. You have to write properly. If you are writing it, your notes, you are revising them. If you are revising, you will get a clear concept and understanding of the concept, how to use the formula, how to use the concept to solve the questions. Okay, different kind of question, what are the models, total number of models in a particular chapter, 10 model or 15 model or 20 model, you have to be clear about it. When you are clear, then you can be able to perform in the paper. Okay, so you should be very clear about it. When you will join the classes, I will tell you in each topic, okay, what are the how many number of types of questions. Even I will give you the numbers when you are seeing how many types of questions are there, what are number of different type of models are there, how to solve them, what are the formulas, what are the concepts, what are the equations, okay, what theory we have to apply. When you are putting it, then only you will get some good marks. Okay, so please understand carefully, be focused in the classes, normal classes when you are joining it. Okay, and from day one onward until the last day, okay, of the final paper of NEET exam, be serious. Don't be relaxed any point of time. You should be, body should be relaxed. You have to sleep properly. I'm not talking about that. Definitely you have to sleep properly, but mentally you should not be relaxed. Your brain should be work in the proper one direction. That the one direction is that I have to learn, I have to perform, I have to learn, I have to solve the questions, I have to revise it, I have to perform in the exam. You have to write all the exam very carefully. Okay, now please reply what are the answer here, the similar question just like 1A, just like previous question. Now tell me what will be the answer here also. Vamsi, Chandana beta, Swati, Mandeep, please reply. Sudhakar, this answer would be also same. This time period would be also same beta. What is the answer? So T is equal to 2 pi under root of m by k. 2 pi under root of m by k. So this confidence you should require in the paper. This confidence should be required because it is not going to change due to QE, nothing. Only due to this equilibrium position is changing. Due to QE only what is changing? Equilibrium position. What is changing beta? Equilibrium position. What is not going to change? Time period. Be clear about this concept. Now this concept is clear to everyone. Please reply in the chat box and put some good reaction in the chat box also. I like that. Okay, put some reactions. It is clear to everyone. Clear beta? Now we are going to understand the one new topic. So today's my focus would be on this point, electric field lines. The new topic we are going to discuss now, electric field lines. Now we have to be clear about it. When we are saying electric field line, what are the meaning? The very first thing, it is the imaginary curve. What is the meaning of electric imaginary curve? I will explain to you. Suppose there is one charge particle is there. Suppose this charge is Q. And from this Q, the field lines are coming out like this. This is the field lines are coming like this. Radially outward. These are field lines. We are assuming imaginary. There is no field line. You cannot see any field line. If the charge particle is placed here, you cannot see any field line. Okay, these are imaginary. For our understanding, we are drawing it. There are no field line in present here. Okay, just for our understanding, we are drawing it. Okay, similarly, if it is a negative charge, suppose I am putting it to negative charge. So from this negative charge, the field line radially inward beta. This is radially inward is there. It is radially inward. It's the radially inward, these field lines are there. These are imaginary curve. What we call it? Imaginary curve. These are imaginary curve is there. Okay, these are imaginary curves. So we are seeing it. This is imaginary curve. No problem about it. It is imaginary curve beta. Now, second point. It is a continuous curve in a charge-free region. What is the meaning? It's the meaning is very, very important. You have to understand. I am taking to you in this point. Just see here. Suppose this is a point charge is there, and from this field line is coming out like this. Suppose this is going out. So this field line is not going to break. What is the meaning of break? This is not discontinuous. I will tell you. Suppose this field line up to here, then discontinuous, that like this. It is not possible. If you say this field line is here, then it is a discontinuous, then field line is here. So there's a gap is there. This gap. It is not possible. It cannot be discontinuous. It cannot be discontinuous if there is no charge. If there is no charge, it cannot be discontinuous. So in a charge-free region, okay, in a charge-free region, it would be continuous curve. In a charge-free region, it would be continuous curve. This should be clear to you. Okay, sometimes it's already asked in paper. The tangent on a curve gives the direction of electric field. Tangent on this curve gives the direction of electric field. In the previous class, I told you already that the electric field also outward. If you see, this is the electric field due to positive charge. And due to negative charge, electric field also inward. So this electric field also inward. This field line also inward. That means if you are drawing the tangent on this curve, it will give you the direction of electric field. Suppose this is the curve, and if I say this is electric field line, coming from some source. So if you are drawing on this electric field line the tangent, this tangent will give you the direction of electric field. This is tangent beta. It is tangent. This is electric field line curve. So in electric field line curve, if you see, you will find there is one tangent. If you are drawing, this tangent gives you direction of electric field. It gives you direction of electric field. It is clear to everyone, beta? This up to here, it is clear? Lashya, Mandeep, Swati, Chandana, Vamshi, Swati, Sudhakar. It is clear to everyone, beta? Please reply. This point is clear? Swati, very good. Other person also, please reply. It is clear or not clear? Mandeep, Sudhakar, very good. Very good, beta. It is clear. Now listen carefully. It originates from positive charge and terminates or negative charge or infinity. So whenever the charge particle start, sorry, from electric field line start, if you any point, there is no space, I am taking to you the next slide, I am writing here. Suppose this is a positive charge, any positive charge is there, and this is negative charge. So electric field line originate from positive charge and terminates on negative charge like this, or start from positive charge and terminates on negative charge, or start from positive charge, terminates on negative charge like this. You can see, okay, these are field lines are coming like this, beta. You can check it. This is the field lines. I'm telling you very simple thing. These are field lines. Okay, you can draw like this. You can draw like this. These are field lines coming out of this positive charge. If you see this negative charge, the field lines are entering from this, entering into this negative charge. This is negative charge, it is a positive charge. Positive charge, it is negative charge. So it originates from positive charge, it terminates on negative charge. Clear beta Rahul, Lasha, Sudhakar, Mandeep, Swati. NEET की I think beta in the second week, first week maybe we can get in June. Rahul, we can get I think in the first week maybe. I'm just expecting this. I don't know what will happen, but I'm expecting maybe in the first week we can get. It is clear to everyone, beta? Now we have to understand some more properties. What are the properties? Come to next point. No two field lines can intersect each other. No two field lines can intersect each other. What is the meaning of this? Listen carefully. Suppose this is the one field line is there. This is another field line. Suppose I am saying these are two field line curve. If this is intersecting at this point, if these field lines are intersecting at this point, what is the meaning of that? Listen carefully. That at this point of intersection, suppose this point is P, there will be two tangent. One tangent on this curve 1. I am saying suppose this is tangent 1. Curve 2, if you see this field line 2, there will be another tangent, that is the tangent 2. This is a tangent 2. This is tangent 1. So how many tangents are there? 1 or 2? 2 tangent. If there are 2 tangent, that means how many directions of electric field are there? 2 directions. Because I told you the tangent on the curve of field lines give you the direction of electric field. Tangent on the curve of field line curve give you direction of electric field. That means this is also direction of electric field. This is also direction of electric field. Is it possible that at the same point the electric field can be in 2 directions? No. Electric field is only one specific direction it will be having. That means at same point the electric field cannot have 2 different directions. Cannot have 2 different directions. That means this is possible or not possible? It is possible or not possible, beta? Reply. It is possible or not possible? Swati, Chandana, Rahul, Ashya, Mandeep, Sudhakar. It is possible or not possible, beta? Tell me. Possible, not possible? Beta, be little more energetic, more enthusiastic in the class. Reply fast. Possible, not possible? Sudhakar, very good. Mandeep, very good. Other person also tell me, beta. Possible or not possible? Okay. It is not possible. Now come to the next point. This point is clear to you. Electric field lines cannot suddenly disappear or cannot be discontinuous if there are no charges present. Actually, this is not this point is not new point, it is the same point number 2. This point number 6, if you see, point number 6 and point number 2 is same. Point number 2 and point number 6 is same. The electric field line cannot suddenly disappear. That means it would be continuous. It cannot be discontinuous. Or it cannot be discontinuous if there are no charges present. If there is no charges present, it cannot be discontinuous. So point number 2 and point number 6 are same. So you can understand it. Now, number of field line in a region indicate the strength of electric field. Very, very important thing. What I am saying, number of field line in a region indicate the strength of electric field. What is the meaning of that? Listen carefully. Suppose if I say here, this is the very common question. The electric field is there. Okay, this is electric field. This is the one case, case number 1. Case number 2. Suppose this charge is Q, and from this charge, the field line, we can see this, the field lines are there. Try to understand it. These are field lines. These are very simple field lines. I have drawn this, the positive charge. Please understand one thing. Please understand one thing. Here I am taking it. This point is A. This point is B. Okay, this charge is Q, beta. This charge is Q. From this Q, this point is A, this point is B. Please tell me where the field would be more. Where the field would be more. What is the value? Field value would be more. Where the magnitude of field would be more, at A or B. Where the field would be more, I am writing the formula, that is KQ by R square. K is not changing, Q is not changing, only R is changing. Tell me where the field would be more, at A or B. Where the field is more, A or B. Reply beta. Where the field is more. Mandeep, very good. Where the field is more. Sudhakar, Chandana, Swati, Niharika. Very good, beta. The field is more at A. Field is more at A. Very simple. Why field is more at A? Because if you see here, if you are taking one region, suppose this region you are taking this much, and the same region you are taking this much here. Same, identical. Now see, this is region 1, this point A. This is region 2. In region 1, number of field line, how many passing through this area? If I say this area is delta S. If I am saying this area is delta S. Tell me from this delta S, how much field line are passing at region 1? 3. At region 2, how many passing? 1. So if number of field line passing in a region is more, that means field would be more. Here B, number of field line passing is less, that means field would be less. Clear this concept? Where the number of field line passing through a region is more, that means field would be more, strength would be more. Now I am asking the same question to you. Please reply. This point is A, this point is B. Now tell me, at A or B? Question 1. Question 1. At A and B, where the field is more? Where the strength of field is more? At A or B? Tell me beta, question 1. In question 1, where the field is more? At A or B? A or B? Niharika, Sudhakar, very good. Where the field is more? A or B? Reply. Lasya, very good. Everyone is saying now A. Very good. Now I am asking another question. This is point is C. A, B, C. A, B, C. You can see there 3 points are there. Tell me, arrange the order where the field is more, where the minimum. More, then less, like this. Okay. So maximum value first, then minimum. Then we have to put it at the last. Minimum at the last, maximum at first. Tell me where the field would be more. Now solve it. Solve it, beta. You have to write order. What is the order? Which is maximum, then which is a little less, then finally less. Write the order. Karthik, Sudhakar, very good. Mandeep, Meharika, Chandana. Beta, write the order. Write the order. What is the order, beta? Lashya, very good, beta. So this is the order. You have to understand it. You have to be clear about it. Suppose you are taking this small area. If you are taking this small area, then you can see at A their number of field lines passing through 3. At C passing through how much? 2. At B you can say only 1. That means as number of field lines are decreasing, that means field is decreasing. What is the order? Field at A is greater than field at C is greater than field at B. This is the answer. Correct answer. Everyone is giving correct answer. Now this concept is clear to you? Clear or not clear, beta? Clear or not clear? Now come to the next point. Number of field lines related to a charged particle is directly proportional to charge q. Number of field lines related to a charged particle is directly proportional to charge q. Related to charge q. What is the meaning of this? Meaning is very simple. Listen carefully. Listen carefully. This charge is suppose 1 coulomb. This charge is suppose 4 coulomb. This is 1 coulomb, this is 4 coulomb. Now tell me, which will produce the more field at r distance? If you draw the at r distance, this distance is r, at r distance, where the field would be more? In first case or second case? Where the field would be more? First case or second case? Because we already know the field is directly proportional to q. Directly proportional to q. If q become 4 times, then field also become 4 times. The field is 4 times, that means number of field line would be also 4 times. Number of field line would be also 4 times. That means if there are only, if I say there are only 4 lines are coming out, so here I have to draw 4 times field lines. How many? 4 times means 16 field line I have to draw. How many? 16. These are only 8. Now I am drawing it 16. These are 16 field lines. So if in the 1 coulomb charge, if it is a 1 coulomb charge, beta, and this is 4 coulomb charge, in 4 coulomb charge number of field line would be 4 times. If charge become 10 times, the number of field line also become 10 times. This is clear? This line is clear to you or not clear, beta? Because field strength become 4 times, then number of field line would be also 4 times. Clear? Sudhakar, Mandeep, Nayarika, Rashya, Chandana. Clear, beta? Swati? Very good, beta. Very good. Very good. Now, listen carefully. What is the meaning? Now, second question comes to you. How many field lines produced by charged particle? For that you have to read the next point. What is the next point? The electrostatic field lines do not form a closed loop. We can write it, but before that I will tell you one more point here. Just wait. I am telling you how many field lines are produced. The number of field lines I am writing here, you have to remember this formula. Number of electric field lines is equal to Q by epsilon naught. Q by epsilon naught. The number of field lines is equal to Q by epsilon naught. Epsilon naught value everyone know. What is the value of epsilon naught? 8.85. 8.85 into 10 to the power minus 12 meter square Coulomb square upon Newton meter square. Yes, that's the Coulomb square upon Newton meter square. You can put it, you will get the answer. I'm just writing little properly here. Just wait. This is the epsilon value. You can get it. The number of field lines produced would be what beta? Q by epsilon. You can write it. Next point. What is the next point beta? You will see. The electrostatic field lines do not form closed loop. Closed loop means, what is the meaning of this closed loop? Meaning is very simple. That means they start from positive, they terminate on negative. They start from positive charge, they terminate on negative charge. If they are not terminating, they are going from negative to positive, then it is wrong. I will tell you. Just focus. Suppose I am writing here. Just wait, beta. I am just erasing little bit from here. You will understand. They do not form closed loop. Just see here. The same diagram I am drawing, what I have removed. This is positive charge. It is negative charge, suppose. This is negative charge, beta. Just see clearly. This is negative charge. So from positive to negative, these field lines are going like this. From positive to negative, it is going like this. But it will not return like this. It is not returning. So going from here to here, returning back, it is not possible. Then it would be closed loop. Going above, returning back, then become closed loop. Not possible, because field line cannot go from negative to positive. It cannot go from negative to positive. So this line is not possible. So what is possible? Possible is reverse is possible. That means it will go from positive to negative only. It will go from positive to negative only. This is not closed loop, because it is going only one direction, positive to negative. It is not returning back to form a closed loop. So remember this thing clearly. They are forming closed loop or does not forming closed loop, beta? Please reply. Forming or not forming closed loop? Please reply, beta. Forming? Not forming. Now, come to the next point. What is given to you? Field lines originate or terminate normal to the conducting surface. I will talk in detail in the tomorrow's class, because when I will discuss the conductors, tomorrow's class would be only conductors. We will talk about it. Okay, in detail we will discuss. Tomorrow's class would be more and more focused only one topic, that is the conductors. So what is the meaning of conductor, how they are different from others, and what is the concept behind it, we will learn in tomorrow's class in detail. What are the conductors? Okay, and in after that tomorrow's class, tomorrow means Monday, I think. Today is Saturday, na? Yes. So tomorrow means Monday. To Monday we will take class on conductors, and then we will go for further, that's the electric dipoles. We will discuss it. Then electric flux, or we can discuss first flux, and then we can go for Gauss law and its application. Then we will discuss that part. Okay, don't worry, beta Manadeep, little bit I will discuss little more. I will leave you, don't worry. One more point I want to discuss first. This number of field lines do not form a closed loop. Before that, I have written the number of field lines related to a charged particle directly proportional to Q. Directly proportional to Q. Just see, just I am taking to you a little blank slide. Okay, here. Just come to this point. Please understand the concept. When I am saying, suppose this is the one positive charge and this is a negative charge. Understand the concept what I am telling. Suppose this charge is equal to Q1. This charge is equal to Q2. Definitely it is a negative, no doubt about it. Please focus on the concept. I will discuss it. Question 1. If I say this is a diagram in the paper, please understand the concept. This is a diagram. This is a diagram. Question 1, and they are asking find the ratio, find Q1 by mod of Q2. This is the question. It is a question. Find the ratio of this. Okay, very first thing that you have to understand it. What is the meaning of this Q1 by mod of Q2? I told you already the number of field lines originating or related to one charged particle directly proportional to Q1. Directly proportional to Q1. So Q1, how many field lines? Calculate. Number of Q2, how many field lines? Calculate. Just take the ratio, you will get the answer. I have given you hint, solve it. Okay, I am giving you another question, another concept. Please solve everyone. I will explain. Don't worry. Right now, I will explain. 1 minute time. Take it. Solve it. Second concept I am telling you here. This is Q1. It is Q2. Both are positive. Again, you have to find Q1 by Q2 ratio. That's the question. Now that we have to understand, very first question, second question, we have to put it. First question, you have put the one Niharika, given the some ratio. Q1 by Q2 ratio is 2. Okay. How to calculate? I told you number of field line is directly related to the some charge particle. So what is the magnitude of charge particle? We have to calculate. So how many number of field line we calculate? That means that directly related to the magnitude. Yes. You will say this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8. So related to Q1, how many charges? How many field lines? 8. So you will say Q1 by Q2 ratio is equal to, sir, here field lines are 8. Okay, now calculate here. This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is 12. We will say 12. Take the ratio. What does become, beta? Divide by 4. That means 2 is to 3. So what is the ratio of Q1 by Q2? Q2 1 by Q2. What is the ratio? 2 is to 3. That is the answer. Answer. First question. That is the ratio. Clear? Clear to everyone, beta? Now, second question also we have to solve. Similarly, we can solve. I'm putting again. This is 1, this is 2, this is 3, this is 4, this is 5. So this ratio is equal to, this is how much number of field line? 5. Divide by. It is 1 2 3 4 5 6 7 8 9 10 11 12 13 30. That's the answer. It is the ratio of the field charges. Clear? Beta, it is clear or not clear? Sudhakar, Mandeep, Niharika. Not 4 beta, 5 by 13. Mandeep, check number of field lines again. Sudhakar, Niharika, Lashya. Clear beta? Clear to everyone? Okay. So in the next class we will discuss, we will start class from here only and we will go into detail. I think it is clear to everyone. If you like the class, please like the video. Okay, YouTube video you can like it. Okay, if you like, if you comment good comments on that, definitely it will give a motivation to us to put more and more useful videos for you. Okay, so please like it and share to your friends and your classmates, your relatives, so that the view and approach to the other persons will be also increases. Okay, their approach to solve the question would be increased, their improvement would be there, concept clarity would be there. Okay beta, thank you so much. Bye bye. Good evening.